Guys, welcome to my channel. This is Karemi. I'm back again with part 2 of the daily plant. So today we are going to visit the second daily plant, which is a continuous daily plant. Like the process is continuous, all the processes batch together.
So this is our old plant. This is old. Actually, this plant was established around 1978. And up to now, this plant has remained to be here. And it was for the same purpose of ensuring that we train our students so that they can be able to be competent in handling milk. So this is our reception unit section, whereby now we receive the milk from wherever they are coming from the farmers, from our own farm. We receive it here. And then once that milk has been received, it has to be, we check the quality first before we can now check on the quantity that is being supplied. So we normally do some tests, which we can also be able to come and show you later. So we check the quality before we introduce this milk into this unit. Then after checking the quality and we get satisfied that this milk is of good quality, it can be able to be produce good quality product, we now take it into the scale where we check on the quantity that has been brought. We check for the purposes of payment, and then after that we introduce that milk into this one. This is a dump tank. We call it a dump tank equipment, whereby we put our milk in, and you can see the design is such that once you access the milk through the filtering unit at this point, so the milk will just get into this tank and you'll not be able to see this milk again. So because what will happen is that it is enclosed, and once that milk is inside here, we have a pump that is going to pump through a filter, still another filter that is a clarifier, which it can be able to remove even the particles that was able to pass through the filter. So those particles are removed at that end, and then now this milk, because it is received at high temperature, has to be cooled so that we are safe, because now the longer we keep the milk at high temperature, then the longer, or even we encourage the microorganisms to grow, which also reduces the quality of our milk. So this is a plate chiller, whereby now we use chilled water, whereby by mechanisms or by the design of the chiller, the water is passing at the other side of the chiller, and the other side of the chiller, it's a plate-like plate. So when you have water passing in one section where it doesn't mix with milk, it is passing at that section, and then the milk is passing on the other side of the plate. So during that exchange, the heat will be transferred from the milk to the chilled water. Chilled water is cold water, so the cold water takes away the heat, and then the milk is cooled. So the temperature of milk will be cooled before now it can be able to proceed to our storage tank. So this storage tank is meant to keep our milk for the purposes of now preparing it to undergo a pasteurization process. So what will happen is that this milk will keep here, and because we have cooled it, we are safe, because we know that milk is coming. Actually, it's coming into this tank at around 10 degrees Celsius. So meaning that milk is safe. Anything below 10 degrees milk is safe, because no microorganisms grow at that point. So once we are ready for processing, this is a continuous pasteurization unit. The one that we had earlier was batch, whereby we are doing it there and cooling, heating, and then cooling at the same point. But now this is a continuous pasteurization unit. So this continuous pasteurization unit means that the milk is heat treated as it continues. Pasteurization continues as the milk flow. So it will come through from the storage tank, it will come to the balance tank. This balance tank is a tank that feeds the pasteurizer. Plate heat exchanger, a continuous one, whereby the milk will be flowing and then meeting also the heating agent. So milk will come in to the plate heat exchanger, and at this point, as it moves upward, that milk is heated. We use steam to heat this milk, and the steam is flowing in the other side of the plates. You can see these are the plates. So these plates are plate-like. So one side there is flow of milk, and the other side there is a flow of steam or hot water. So that hot water will heat the milk, and this milk will be heated. If it is pasteurized milk, we'll heat it to 72 degrees Celsius, not minimum than that. That is the minimum temperature that we expose this milk, which renders it safe for human consumption. But immediately after heating that milk to above 72 degrees Celsius, we use also the same chilled water to be able to cool it, to bring down the temperature into 5 degrees Celsius. So we ensure also, as you heat that milk to 72 degrees Celsius, you bring it down quickly to 5 degrees Celsius. So that is the work of the pasteurizer. And then from that, now once that milk has been heat treated, we have also a mechanism that this pasteurizer can be able to ensure that this milk as it leaves to go to the storage tank, it is properly pasteurized. And this, we have an instrument that is called flow diversion valve. So this instrument is a very sensitive instrument, whereby now it has been set that this milk will only go forward, will go to the storage, before we go to packaging, when it is above 72 degrees Celsius. So anything below 72 degrees Celsius, this valve, it's a valve like, it will not encourage milk to go forward. Otherwise, it will return that milk back to the ballast tank, whereby again the milk will come again for pasteurization. So this one determines whether the milk has been fully pasteurized or not. So if fully pasteurized, then that milk comes to the storage tank. So it will come here into the storage tank, whereby now this milk is coming in at 5 degrees Celsius, and this is the point whereby now we consider that milk has been pasteurized from the raw, and now it is pasteurized milk. And at this point now, you can now take it to the packaging, whereby now you can pack into various packages that you want. This is our packaging machine, and it uses polythene to pack. So this packaging machine is able to seal, to make a bag actually by sealing, and then it again fills and then fills the product, and where you have eventually the product coming out in a package. So this machine is able to do all that. It's able to seal, make a bag, and then fill the milk, and then seal it, and that milk is ready for storage. So once it is ready, at that point, this milk comes to this cold room. This is a cold room, whereby now it is you can call it a big refrigerator or big fridge, whereby now it can be able to accommodate bigger volumes of product. So once this product has been packed into packages, we take it inside this room, which is a cold storage room. That cold store is meant to keep that milk remain at that temperature. So for fresh milk, it has a brief shelf life. It goes up to 14 days under refrigeration. Otherwise, if outside, it can stay for 3 days. So cold store is meant to keep the milk at the quality that was processed. Also, this equipment, this is a butter churn. This butter churn is meant to break cream into butter. So we access the cream inside here. So once you access the cream here, and then you close, this butter churn normally rotates. So as it rotates, it is shaking the cream which is inside. So it will shake up to a point. So as it shakes, actually the cream normally makes this glass not become transparent as it is. It makes it opaque, so you cannot be able to see inside. But as the agitation continues, that is the churning, as churning continues of that cream, where it will reach a point that this glass become clear. So once it become clear, it means that now the cream has been able to break into two portions, whereby we have the buttermilk, that the one that is washing this glass, and then we have the butter granules. Butter granules are the grains of fat that has been able to be formed, whereby now you have been able to break the cream into two portions, buttermilk and then butter grains. So the butter grains are the one that we are interested in, to be able to mold it and it become butter. Otherwise, the buttermilk, we drain it off. We have a draining valve. That draining valve is meant to remove the watery portion, that is buttermilk. So buttermilk will be drained off, but that buttermilk still can be used for feeding animals. And if it is a fresh cream, we can still take it back to the processing with other milk. It is just as fresh as the other milk. So this also is a butter churn still, a small capacity than the other one. So working with the same principle. Our batch pasteurizers also. So when you are making yogurt, you can be able to do it here. And this one uses steam. So we access the steam into the batch pasteurizer. So this pipe works, you see insulated. Also, those ones introduces steam inside this and hot water. And then you see the green ones introduces the chilled water. So this batch pasteurizer means that you are going to introduce the milk here, heat that milk, and then cool at the same point. That is why it is called batch pasteurizer. Now we have also refrigeration equipment. This is a refrigerator whereby products at small quantities can be kept also here for the purpose of ensuring that they keep at very at the quality that we have. Because once we expose this milk product into high temperature, then we reduce the quality. And only make sure that we are environmental friendly. So this is a solar refrigerator. So it's a clean energy. We are not doing a lot of damage to the environment when you're using this one. So for sustainability, also we are encouraging that people should be able to use this one, because there's a lot of emission from the other refrigerator because they are using refrigerant. But otherwise, this is a solar refrigerator whereby now we use solar to cool the products. And this one is a sustainable way of doing that. We had a project whereby we were encouraging the packaging in a simple way, whereby now the pasteurized milk could be accessed into this tank, and then from this tank now you could measure the quantity of milk that you want, if it is 500 mils or a half a liter. So you can use manually fill into the pouches or bottles and then now seal them. So it's actually a simple packaging machine. It's a manual kind of packaging machine. So if you are using pouches, then there's a sealer that is sealing it. So once you have filled your milk here, then the sealer is here, whereby now you'll be sealing occasionally. So you'll put your package that has milk, and then you can use the foot now to press. And this is because it's a hot plate, then with a brief press, then the seal can be able to be formed. Those are the two plants that we have here, and actually we are doing that because of increased population. Initially, when we were using the old plant, we were doing only for 10 to 20 students, but currently we are handling up to 100 students in a program, meaning that we need a space. So that is why we have the two of them, so that at least using the two trainers, you can be able to split them into two groups, and you can be able to facilitate the training easily. This is the home of dairy training. DTI is the only institution, tertiary institution, East and Central Africa. We don't have any institution that is dealing with dairy. Others could be doing it in a very small way, but this is a recognized institution, East and Central Africa. We don't have any. In all these countries, this is a place of dairy technology. So anybody who wants to come and train in dairy technology, this is the best place for that person to be able to acquire the skills that are required for dairy technology.